There's some other information we can determine from a quadratic without necessarily having to graph it. Some of the information we want to look at is, well, what's the maximum point or the maximum value of this graph or the minimum value? We want to determine what its domain and what its range is. And we also want to determine, well, we'll start with that. Let's start for right now is, does this graph have a minimum or a maximum? Well, the two things that we can determine is one, that a coefficient in front of the x squared is a -3. So we know that the graph will bow downwards. So the vertex of this graph is at its highest point. So this graph is going to have a maximum. It's going to have a maximum value. There's going to be no values greater than the certain point. Where does that value happen at? Well, we can determine by looking at its vertex. And the vertex, the x-coordinate of its vertex, was at the point -b over 2a. That gave me the x value, and to find that out, that's a -6 over 2 times a -3, and that's at the point 1. And take that 1, I input it back in, and that's going to tell me where its y value is at. So this function, evaluated at 1, (1 squared), it gives me a -3, plus 6, minus 13, 3, gives me a -10. So the vertex of this particular quadratic is at the point 1 and -10. So my maximum value I will see is at the value of over 1 down 10, at -10. And the last piece that we want to find out from this that we can determine is what its domain and what its range is. Well, all quadratics, the domain of all quadratics are all real numbers. That's one way to write it. Interval notation, -infinity to +infinity, or all x, such that x, well, what's the best way to write that? X is between -infinity and +infinity. I guess there's lots of ways you can kind of look at it. Again, interval notation is my favorite, but the domain is all real numbers. Every number I can think of, I can put into the function. What's its range? Well, its range is its y values, and its vertex is at -10, and we knew that -10 was a maximum value. So its range are all numbers less than -10. And the best way to write that is -infinity to -10. And actually, -10 is a solution, so it's going to be a hard bracket right there. So those are some of the things I can tell without necessarily having to graph it, what's going on. But I want to graph some of these components too, just to kind of help make sense of it. There's a rough graph. I know I have a vertex at -1, or a 1, -10, which is roughly right about there. I know the graph opens downwards. And that kind of helps me have an idea what its domain and range is. Again, its domain are all real values, and its range are all these values right here on the x-axis. And that represents all the numbers from -10 to -infinity, written as -infinity to -10. So there's some more information that we can discover, but it's going to be up to you to practice this. It's going to take several problems to get the idea of there's information here, how do I unlock it, and where do I find it at?